All right, we're going to walk through a video showing just one of many techniques that can be used during a hasty pickoff. This one's context is very specific to really a depleted organic asset environment where you really don't have enough manpower and you don't really have a lot of kit. So being able to access that person that's stuck, injured, shot, whatever that case may be, where you have got to physically do a load transfer to get them over onto your system and then be able to bring them down to the ground where they're hanging there. So like we said before, this is just to kind of reframe this problem. Not to say that this is a technique that you should ever do. The context for this is really specific. But I will say any of the techniques that we show in the series of pickoff videos that we're getting ready to do, we've used for a long time. They've been used quite a bit. They've been used on actual rescues before, so it's not really theoretical crap that we're going to be throwing your way. It's just showing you there's different ways of doing it out there, and if you reach that point where your primary is not an option, your alternate is not an option, and you get into that contingency and emergency, you definitely need to plan for that and figure out how you're going to handle that situation. So moving on real quick, this is a hasty technique for organic asset depleted environments. The preface of this, like we said before, this is one of many techniques to accomplish a pickoff on an injured or stuck person in the vertical environment. It is engineered for a very depleted environment of both personnel and equipment. As another preface, we utilize single rope techniques 99% of the time. I know that when we get into this and your department, your agency, they require belay lines and twin systems and whatever that you do. We typically don't utilize that for the environment that we go into and the environment we train for. So keep that in mind. Your techniques may differ drastically, or you may figure to yourself, you may never be in that position where there is no one else to help you get down there. You wouldn't be lowered and you'd have to do the entire rescue yourself. Anyways, we do use belays sometimes when we are usually improvising. So whether we're using bed sheets, electrical cords, or something like that, and we're having to improvise for that vertical environment, it's typically when we do it, or it's something so odd or sketchy on an anchor, then we'll usually put like a meat backup into that or something like that as far as the meat anchor goes. Anyways, we build and input any needed redundancy through basically requisite diversity as far as mindful redundancy where it needs to be and doing it effectively when we build systems. So we aren't just throwing things out there. And even when we look at this technique, we'll talk about potential failure modes, analysis of what could be going on. As far as the gear we're using, we are using the new NAR 8mm Olympus rope on this, which I think is going to be coming out probably in the first 2 weeks of August. Phenomenal rope, really dig it. We're also using, in this video, it's their prototype. This is actually a picture of the final version of their individual mechanical advantage system. It weighs, I think, right at about 2.4 pounds, so it's super light, can fit right into a side pocket. Throw it in your bag, kind of throw it anywhere. It's very small, very compact, very adaptable to different environments. And in that, this is kind of how it's packaged. This is the kit itself. And then we are using a totem as our descent device. Obviously, the 8mm per cell, or the VT prosthetic that's in the kit too, is a vital portion of this. So just making our way back through standards. Want to make sure that people understand that when they look at this, they don't just negate it immediately thinking, oh my gosh, that goes against every standard that's out there. We have a very poor understanding of the standards that we follow typically, just because they're written in such a way that is very boring and most people don't want to read them. As you've heard probably in a lot of our podcasts and things like that, we utilize NFPA in enormous amount, 1006 specifically, sometimes 1670. But that being said, when you dig into that, you will suddenly realize a lot of the things that maybe you've been taught over the decades that you believe is in those guidelines that dictate how you're supposed to roll, what you're supposed to use. When you read through those, you will probably be surprised at the fact that they aren't in there at all. It was somebody that taught it to somebody that taught it to somebody, and now it's become truth, when in reality, in most cases, it was actually never even in any of the NFPA guidelines. So that being said, where pickoffs are mentioned in there, we can look under Chapter 5. Obviously, Chapter 5 is the rope rescue section that covers awareness, operations, and technician. So if we look under the 5.3, which the 3 represents the technician level items and job performance requirements, it begins to mention it as far as direct a team in the operation of a rope rescue system to remove a victim suspended from a rope or webbing in a high-angle environment. And it kind of goes through your givens as far as those things: getting suspended by a harness, attached to anchored rope or webbing, blah, 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 blah. 5.3.3 with an asterisk up there, we'll talk about here in a second, is while suspended from a rope rescue system, perform the transfer and movement of a victim suspended from rope or webbing in a high-angle environment to a separate rope rescue, lowering, or mechanical advantage system, which is more consistent with what we're going to be doing this. So we'll be taking them from their tension rope over to our tension rope, obviously because we are on it. As far as those asterisks are concerned, this is what it basically takes you to, is the appendix, Annex A. And we'll see under there, the first one is the urgency of performing the transfer of patients suspended from fall protection lanyards. Pickups has received much attention due to an increased awareness of profound effects and rapid onsets of suspension trauma or suspension-induced shock syndrome. Rescuers should recognize the need for rapid removal of persons from these potential life-threatening situations. The reason we put that in there, one, it deals with what we're talking about in this video, but number two is how prepared are we to go from our primary, this is the way we always do it, into an alternate, into a contingency, into an emergency. If you think about even our old school protocols of doing rapid extrication with people when we were able to, you know, kind of bypass full C-spine precautions and Kendrick's kits and things like that. There were certain things with the risk of their life and fire of the vehicle and all these things that kind of went into there. We need to think about that on rope also, is do we want to take that time? Can we take that time to build such a redundant system, in some cases almost ridiculously redundant, just to be able to get down there to save somebody very quickly, when all the time that we're building these systems, that person we're supposed to be rescuing is not getting any better. There's not a pause on their injury. So we need to think about how we can move quicker. And it may be an issue where there may be environmental pathology as far as weather and things like that, that is going to require us to get down there quicker for the safety of not only the casualty, but the safety of us. That's going to be another podcast that we're going to be doing here in the near future, and bring out actual incidents where people found themselves kind of like a deer in headlights going, oh God, do I break from the strict rule that our team adheres to, and this is the way we do it, and not even knowing another way that they could do it quicker and usually just as safe with the same safety factor, and be able to exponentially decrease the time in which we can reach that casualty, get them down, and get us to safety along with them en route to a hospital. And then obviously the last one that's asterisk basically says the specified minimal travel distance, how high you're doing this. This is pretty much consistent with all of NFPA on when you set up how high you're going to be ascending, how high you're going to be descending from. The travel is for your mechanical advantage for your hauls, lowers, your raises, is going to be specific to your team and what that normal space is going to be as far as that distance and height that you're typically working at. So that's all that one really says. And we'd be remiss if we didn't go through really quick on 1983. So with this, and a lot of the kits that you're going to see coming out from North American Rescue that we're fortunate enough to play a role in helping to design with them, along with some phenomenal manufacturers, we've kind of fallen into this scope where there's an enormous amount of gear out there for people that have to follow NFPA 1983, which 1006 never tells you, but in 1983, their departments say, hey, we need everything to be NFPA-G, NFPA-T rated, and that's kind of a whole nother discussion of misunderstanding at times. But understand that 1983 is actually a manufacturer standard, not an end user standard, although the end user can gain good knowledge and insight when trying to purchase something very specific, because you will see all their testing procedures, the labeling, making sure you're buying something that you're supposed to be buying and it's correctly labeled, and that type of thing. When it gets into thermal resistance and things like that, it can be useful just so you know what you're buying, I guess. Many of our rescue techniques are for those who fall under NFPA 1983 under the scope of 1.1.5 and 1.3.2. This is kind of the I don't want to say bastard children, but often ignored, where they end up having to unnecessarily carry a lot heavier gear than what's mandated because people don't dig in and read these things. But under 1.1.5, it says this standard shall not specify requirements for any rope-associated equipment designed for mountain rescue, cave rescue, lead climbing operations, or where expected hazards and situations dictate other performance parameters. So besides thinking, oh my gosh, you know, what could fall under here? A lot could fall under here. If you find yourself an urban team that does regular tech rescue, but also has a mountain area that you may respond to, like areas in California and Rancho and in those areas where you kind of got this dual role, know that you get the out to be able to use faster, lighter equipment that's just as safe, especially if you know how to engineer a system, that you're not stuck to having to carry steel things or really large diameter ropes. They give you the out, let alone units in US SOCOM or anybody doing any type of hazardous maneuvering where it dictates other performance parameters. You may need different fibers. You may need obviously different weights. You may need other performance parameters. So this is your out for those people doing things in high threat environments. And 1.3.2 backs this up with the standard shall not apply to rope or equipment for use where specific situations dictate other performance requirements, such as mountain rescue, and they basically go right through, lead that through, and also include general industry and construction demolition. Now, getting into the technique. If you are unfamiliar or need a review on different ways of tying a VT plus stick, go to our website or go to our YouTube channel, and we have a new video on there as far as how to tie a VT, how to do kind of a augmented version of that, which is called an XT, and then there's actually a modified XT. The technique that you're going to see the rescuer using in here is actually a modified XT. All of them have different properties depending on the diameter of rope you're using, the material of rope you're using, how much weight you're placing on it. So we've had to change that around a little bit because we use VT classics a whole bunch. So that being said, if you need practice on that, then just check those out, and they're pretty darn easy. So let's get into this video, and we'll kind of walk our way through it and discuss those pieces as we go. One thing that we need to talk about is when we're hitting this, we start this off with obviously the kit, and this is kind of a big part. So due to this being a one person, we could throw everything in our pockets, everything in a fanny pack, rappel down to them, stop ourselves in that normal area where butt's somewhere around their head or shoulder, so we can raise them up and do that load transfer by taking their tension system off them once we gain them up into a mechanical advantage. For our purposes, we usually have our rescuers pre-tie everything when they're flat on the roof or wherever they're getting ready to go out, instead of doing it at vertical with the potential for dropping something, and you're hanging vertical and you may be exposed depending on what the threat is. So a lot of times we'll pre-rig those things if we're doing a single person rescue while we're still on that roof. And so that's what was done on here. So the person rigged the VT plastic in a modified XT configuration, threw on the set of fours, took the other set of fours, and just put it on their harness. Then makes that edge transition. Also, should probably mention something about using a set of fours. A lot of people will use pick-off straps, which you find yourself kind of jerking, especially if it's somebody heavier, and trying to maneuver them up. Keep in mind too, when we practice that, you may want to just make sure like whoever you're trying to rescue just gives you dead weight. And in that, you're going to find it's a lot more difficult to use one of those little pick-off straps, because really, technically, they say you're lifting them up on a 2-to-1. There is no pulley. There's a ton of friction. It's almost like using a rigger's belt to be able to bring somebody up on that, which is not easy. A lot of times, the people that we may be training with are in kit, carrying a lot more gear. Where that kit they're in can add, anywhere from 30 to 50 to 60 pounds more onto them. So we typically just say, screw it, we're going to use a set of fours. And the set of fours that we're using, obviously, are the new one from North American Rescue. We use for so many other things, so it's not really an inconvenience or kooky for us to be carrying that, since we use them for your regular piggyback mechanical advantages. We do it to adjust, making adjustable change of directions, adjustable artificial high directional pieces. We use it obviously for attendant positioning, for doing litter attendant. We also can use it for casualty positioning. We back tie anchors with it. We pass knots with it. We do a whole bunch with it. Rig to lowers, rig to raise conversions. So having that with us, especially small and compact, is not really a big deal. So let's look at the technique. All right, so he's already reached the casualty, stopped himself where his butt is around that shoulder area, and undoes, releases that rope down there, releases the cam on the jag, rolls down, and this first carabiner is actually, and this is the older prototype before we put the ARS on there, goes right into their belay loop. He goes under that belay loop, which makes it much easier to release his system. As he goes in, he releases the cam, takes that VT prusik and shoves it up as far as he can that he can still reach with his left hand. Make sure that that cam is locked, and then starts to pull down. And as he's doing that, he's pulling that guy up on a 4-to-1. There we can see that he's got slack in his system. He undoes that casualty's descent device, manages his rope, gets it kind of out of the way, and then he's just going to position him where he can control him. At that point, this is kind of critical, that casualty is hanging from the VT prusik. He doesn't have a second point of attachment. And that's going to be something that some people will bring up as a potential safety issue. The other side of that is the questions that will come up. What if that VT slips with the casualty on it? Very unlikely, because if it's going to slip at all, it's when you're applying that force from the mechanical advantage, especially in the configuration it was. So as he's pulling down on a 4-to-1 with a change of direction, remember when we count tensions, that's actually 5 tensions that are put onto the VT prusik because you're pulling against what would be your anchor. And with that, that is actually more weight than what the casualty is. So if you mistied it, and you're worried about it slipping, it's gonna slip the second you try and pull it if you didn't tie it correctly. VTs absorb a lot of force, and it's very rare that you'd ever have a VT tied improperly if you know what you're doing. So that's one thing. The other side is, okay, he's only got 1 point of attachment. Super unsafe. It's not super unsafe if you know what you're doing and know your system, know the behavior, and actually know how to safety check it. So the only thing that would really technically be unsafe is if you're scared that that VT is going to blow out. Our VTs are from Blue Water, the ones that Rich Carlson designed. They are Technora. We use Aramids VTs, and we use Aramid ropes. So we're not worried about glazing on that whatsoever because of the heat resistance of Aramids. So the only side of that is if you and your team do not actually check your equipment. If you had tears or there was some sort of material failure of your VT, then that's a legitimate concern. And what I would tell you is learn to check your equipment and don't go with blown out stuff. You typically aren't going to keep a rope in there that's got core shots all over it. Same thing with your VT. So whereas we're using an Aramid VT on an Aramid rope, we can definitely gain friction, and heat is the side effect of that. So that's why we use Aramids on there. So the heat that we generate is nowhere near anywhere from the decomposition point of this VT. So he is on that thing. What if he starts coming down too fast as you're bringing him down? All that means is he's going to jam into your descent device, which no harm, no foul. Nothing's bad going to happen. You just let him grab. You go down a little bit further, and then you start bringing him down when it's comfortable again. The nice part about this too is because it's one-person rescuer, at no point do you have to adjust more friction, because as he's repelling, he's unlocking, and he's in vertaco there. As he's unlocking his system, he doesn't have to add friction because now he's got not only his weight, but somebody else's, the casualty's weight on it. The casualty's weight is completely on the VT. So let's continue this thing on here. He grabs up, starts moving that down with his hand, and he's lowering himself on the vertaco, and there's such little weight, he's actually breaking his vertaco behind him and not even up, which is the thing, until you get to the ground. So that being said, that is one technique of many. Try things out on yourself, reframe the problem, understand, and come up with plans for what will happen when you are in a depleted area, or environmental pathology, different threats, or patient condition dictates that you've got to execute this now. Your equipment's strong enough. You just need your brain to be strong enough. You need your understanding of the materials that you're using, the behavior of them, and how you can go lightweight and fast and get the job done. And that is it. If you have any questions, definitely email us at Element Rescue and info@Element Rescue or Sean at Element Rescue. Thanks.